Let's see, I think we're recording. Get a full screen here. All right, so about to do 20 problems, and these same 20 problems are going to be coming your way for quite a while, I imagine. And we'll build off them. We'll look at problems that are connected to the following and try to get a foundation started here. All right, so this is what you're going to work on tomorrow in class, the exact same problems that I'm doing for you now. And all I want you to do is relax and watch the video. And then we'll see if some of that muscle memory returns tomorrow morning in class. And if you do those problems correctly, then we'll move to the next one. And if not, we'll do 2 or 3 more. And we'll keep doing 2 or 3 more until it starts to make some sense. And that's how we're going to approach this now. So I've tried to pick what I think are some of the most important processes and things to consider. All right, everything here, I think, is something you want to have in your pocket at the end of the semester. So let's start working towards being able to put them there. Problem number 1, equation of a line through 5-7 and 11-26. Nothing new here. Trying to learn this now for a bit of a stretch. So 5-7, y equals, make some space here, a little more space, put the parentheses out here a little further. Because I think you have that down based on what I'm seeing in class. And then the question is correctly computing the changes that you see in the table. I suggest a little number line work. Not that you really need it here because 5-7, 5-11. Right, I think we can see what we have to do to get from 5-11. Change to 6 units. And 7-26, we're not working with any negative numbers, so 7-26. Well, I know 7-27, I know what 7-27 is, that's 20 units. Looks like I'm going 1 less. And that's what you're gonna try to do tomorrow. All right, and as we do more problems in class, we can talk a little bit about what the next series of data are. I mean, that went up by 6, so up by 6, up by 6. It's useful to know this too. And then 26, 7-26 was up 19. So add 20 and then drop 1, add 20 and then drop 1. Those data points should work. Let's see if 2364 works. So 23 minus 5 is 18. Oh yes, 18 is a multiple of 6. Goes 3 times, 3 times 19 is 57 plus 7, 64. So I'm just mentioning that, but the only thing you have to do tomorrow is get that equation. All right, and we'll keep working with it in class like I just did a moment ago. Let me get an eraser. 1 down, 19 to go. And some of those 19 problems are really 10-second questions once you learn what you have to do with them. And that's all we're doing right now. It's trying to do a little language work. And I've got the problems in front of me here. So foiling is an important Algebra 1 skill. 5 minus 2i times 3 plus 4i. Okay, more times than not, you'll be working with things like x minus 2 times x plus 7, things like that. But let's interweave what we started working on today, because you do have to learn it. And so you can learn your foiling by working with these imaginaries. So 5 times 3. So what you're really doing is 5 times 3 plus 4i. You're doing that times that. And you're doing minus 2i times 3 plus 4i. And then you're going to combine those. Okay? And the way we do it, generally speaking, is multiply the first numbers in the parentheses, get you 15. And then we do 5 of those 4i's, which make 20i. And then we do the ones on the inside, minus 6i. And then we do a minus times a positive is a minus. You got to be careful here. 2 times 4 is 8. And I times I is I squared. Okay, so for instance, if we did, let's see, what can I do? If we did 4 times 6, well, that's 24. And we know 4 is 2 plus 2. And we know 6 is 3 plus 3. And that's gotta come out to 24. We have 2 3s, which is 6, we have another 2 3s, which is 6, we have 2 3s there, which is 6, and we have another 2 3s, which is 6. They're all 6, each multiplication, and there's 4 6s, and there's your 24. So the mechanics work. All right, I'm gonna try to talk a little less as we go through these. So you just watch them, you don't have to spend too long. We'll have our conversations in class. All right, so these are like terms, 20 minus 6i is 14i. And 15 plus 14i minus 8i squared is the same thing. Minus 8i squared is equivalent to minus 8 times negative 1. All right, so that makes it positive 8. So I squared changes the sign in front of it. You'll keep hearing that. 15 and 8, those integers should be combined, plus 14i. Those are not like terms, so you're done. That's problem 2 tomorrow. Problem 3, we have a vertex of a quadratic at 4 3. All right, so if that's the vertex and we want to write this in graphing form, x minus 4 squared plus 3, very similar to the linear process you did a minute ago. And now we have to get the conversion. The conversion is not the same as linear. Our conversion has another operation in it. So when I put the next number in, which is 11, what I've really done is gone from 4 to 11, and then I want to square it. If I square it, I'm finding the area of a square, and from 4 to 11 is 7 units for the base of that square. So the area generated is 49. And 49 plus 3, we want to find out if it takes us to the y value that matches up with an 11. And that is problem 3, and that's a 2. I don't think from 3 to 2, 49 takes me there. To get to 2, I think I need negative 1 plus 3, not 49. Not 49 units of change when I plug an 11 in there. That's what I get. I want it to go down 1. That's the equation you're going to try to generate tomorrow. So think about it tonight a little bit. Think about the process and then see if you can do it each and every time. I have faith that you can if you stick with it. But I've seen enough students, if you bail and you stop thinking about it, it won't ever come to you. So every day, and put a smile on your face until you get it. You got to a midterm. You got 25 days to learn that. At least 25 more classes, I'm guessing, to learn that. So stick with it. Now we're going to expand 3 times x minus 5 squared plus 10. All right, we're trying to learn to think mathematically, which means x minus 5 squared, we're going to do first. It's the hardest operation. That's how you read math, and that's what x minus 5 squared means. We just did that a minute ago with another problem. So x squared minus 5x minus 5 times x minus 5x minus times a minus, a positive. 5 times 5, 25. So that's x squared minus 10x plus 25. All right, now we put that right over here, and we see, could we have done it? Could we have gotten that binomial squaring, that x squared minus 10x plus 25, without having to do the parentheses and parentheses, because I'd like you to be able to square that and just write that with even more difficult ones later. Now we have 10, so let's just look at it. Oh, you square the first term. You square the last term. Squaring a negative is a positive, so when you square the last term, first and last terms are both always positive. Can you think of a way of looking at x and negative 5 to get minus 10x? And I hope you see that over here. We have a product of the two numbers, minus 5 times x is minus 5x, and it appears twice. So maybe you'll be able to start doing that a little more quickly and easily over time, but we'll always do it both ways. And so this expanded is 3x squared, 3 times minus 10 minus 30x, 3 times 25, there's 75 cents, 3/4, add a dime, right? 85. That's what I hope you do tomorrow. Next problem. Next problem is number 6. We're already on number 6. No, I skipped one. Number 3. You'll be doing number 3 tomorrow. Now this probably is a little new. But at the same time, it's one that I think will give us some good practice, and you need to learn it, so let's put it in front of you. And all I'm asking you to do is perform f of 3. And it may be the very first time you've ever heard it. Somebody asked you to do something like this. If that's the case, and if you haven't seen that before, then I am now giving x a value. It's 3. And what f stands for is a series of operations. It could be one operation, 2, 3, or it could be all these operations. And so what am I doing over here? I'm replacing x with 3. So those are like portals. Over here, I'm going to do 4 in a square. And so I'm just dropping the number in place of the letter. And now I have a calculation. Question is, do I know the order of operations? I hope you know you square before you multiply. So that's 4 times 9 minus 3 minus 7, which is equal to 36 minus 10, which is equal to 26. So what is f of 3? After I use this x value, I get an answer of 26. I hope you can see that. Not the, yeah, I guess you can see it. Let me get a different color marker in here. See if I can get a little bit more. Get it a little darker, so bear with me. I'll be there in about 2 seconds. 2 more seconds, and I'm there. Let's see, I have the refill. I'm walking over. Put it in the marker, up and running again. All right, so now we're on problem number, oh, I think I repeated 6. So, okay, so we're on 7 on your worksheet. I actually put this problem down twice on the sheet, little typo error. We'll ignore it. Okay, so we have been working and we will continue to work with 2 times 2x squared minus 16x plus 5. We're going to graph it. All right, so what can we say already? Well, we can say it's a cup shape up graph because the multiplier is positive. I know the y-intercept. If I put a 0 in, I get 5. It's the only time you've heard this was today, but I'm decreasing and increasing, and the middle term tells me it's on this side. You don't need to know that for a while. So the only thing you're missing here from graphing form is the vertex. It's the only thing you're missing. So, repeating the question, how do you find the vertex of a quadratic? At some point, I'm hoping you say what? Oh, let's let x equal minus b over 2a. Because that's going to tell me that x value. So what's minus b? Positive 16. 2 times a. A is also 2. Well, 16 divided by 4 is 4. So I can now write x minus 4 squared. I found the value that's important. I know I have a multiplication by 2. The only thing I'm missing is what goes with the 4. Well, the original equation will tell me. So if I put a 4 in, I square it first. 16 times 2 is 32. 4 times negative 16 is minus 64. I know I'm right because I have the middle term is twice the size of the first and they're opposite. This is positive, that's negative. So this number is correct. And I still have to add 5. Whenever you add the first 2 numbers, you always get the opposite of the first one. So 32 minus 64 is minus 32 plus 5 is negative 27. It's now in graphing form. And 4 gets me negative 27. You have sketched with the least amount of data that problem. There's a ton of other x values and y's all over the place. The symmetric one is over here at 8, 5, same height, right? So those are 3 you can get pretty easily. And we'll keep practicing them until you do. Your first chance to show me a little scrimmage on Friday. So you got tomorrow and Thursday to try to sort that out. And let's hope you can. If not, you got next week. And if not, then you got the week after. All right. So now x squared plus 5x as a product. So this is called the sum. You're adding something. We're gonna write this as a product. So let's see if we can write the sum of 40 plus 50 as a product as an example. How would I write that sum as a product? Well, they sure seem like they have a common factor of 10. And 10 is times 4 plus 5. Yeah, I think 40 plus 50 is 90. And 4 plus 5 is 9. And 9 times 10. I would say I've written it as a product. So what's the first rule? The first rule is the one I just showed you here. What's common? What do these terms have in common? And I hope you say the letter X. What do I have to multiply X by to get X squared? Another X. What do I have to multiply X by to get 5X? 5. So let's let X equal 3. 3 squared is 9. And 5 times 3 is 15. And 9 and 15 is 24. Let's put the same number over here, which is 3. 3 times 3 plus 5 is 3 times 8, which is 24. It seems to be working for a randomly picked number. I have a feeling that works for all numbers. And what we have on the right side is a product. And in another class, someone's going to ask you to factor x squared plus 5x. And I'd like you to know what factoring means. Factoring means writing sums and differences as multiplication. All right, so that's going to be on there. The worksheet tomorrow. Let's see if you remember how to factor. And I'll use the word factor, but it means write a sum as a product or a difference as a product. The next one, same question. How would you write x squared plus 5x minus 6 as a product? Well, that's a little bit harder because there's nothing common. First two terms have an x, but the last one doesn't. So I can't take an x out because they don't all have an x in them. And I don't think 5 and 6 have anything in common either. So this is when we have one of those parentheses times parentheses situation. And I hope you can see why I'm putting x in each of those parentheses, because that gets me the first term. The number here and the number here get multiplied. And when you do that, you get the last term. So it looks like I have to have two numbers that multiply out to be -6. And when you combine that multiplication, you get the middle term. And that's a combination, that's an addition. So there has to be a multiplication that gets us +5. All right, so can you think of two numbers that multiply out to be -6 and add up to 5? Well, there's a way to do 1 and 6 to get 5, and there's also a way to 2 and 3. If I want to get 5, but a negative product, now that's a problem. Because I don't know how to get a negative product if they're both negative. So that knocks this one right out. Immediately knocks it out, because if they're both negative, it multiplies out to be +6. And they can't be both negative because they got to add up to +5 anyway. So that's out the window. So how do I get this to be true? Well, it sure looks like the 6 has to be the big one here. And the 1 needs to be the negative. Because -1 plus 6 is 5, and -1 times 6 is -6. So it sure looks like this number had to be -1, and this number had to be +6. And I hope you can see the foiling that we did earlier to create this trinomial. A trinomial is a 3-term expression. And we're going to be doing a lot of them every day from now on. So now we have another problem. Let's see. How do you factor? How do you write x squared minus 2x as a product? Hope your brain just said, take out what's common. What's common? X. That's very similar to a problem we just did a second ago. So if you recognize what to do, you're going to do it right. How do you write x squared minus 5x minus 14 as a product? Well, that doesn't have an x, so I can't take out anything that's common. So I'm back to one of these. Can I do one of these parentheses times parentheses? I sure as heck can do x times x, right, to get the first term. And now I'm looking at multiplying a number times a number. That gets me 14 and has something to do with 5. Hope you said 2 and 7. Yeah, it's got to be a plus and a minus because I'm getting a negative product. The question is, which one do I put the negative in if negative 5 shows up here? Well, if you put it there with the 7, and you can see kind of a size tug of war between negatives and positives, and that's a bigger number in terms of magnitude. So it wins out. So x times x is x squared. X times minus 7 is minus 7x. 2 times x is 2x. And 2 times negative 7 is minus 14. And I hope you can see what you get when you add minus 7x and 2x. You get that. So they're the same. You can always check them with a number. You could throw a 10 in here. 10 is 100, minus 50, minus 14. If I use the number 10, let x equal 10. That's what I get on the left side. I get 50 minus 14, which is 36. Let's see if the product gives us 36 if I use the number 10. 10 plus 2 is 12. 10 minus 7 is 3. Oh yes, 3 times 12 is 36. That's the same calculation as this, but expressed differently. Now, why might we want to do that? Why might we want to learn this skill? Well, what if on this side I had divided by x minus 7? Over here, it looks a lot easier when it's x minus 7, doesn't it? Because those numbers cancel. You don't have to multiply. Let's multiply 3 times 10, then divide by 10. 3 times 10 is 30, divided by 10 is 3. So this parentheses multiplied by that number, then divided by that number, gives me what I started with. We'll keep talking about that every day, now that we have this worksheet in front of us. All right, and so now that you've done those, let's see if we can use some information here. Length times width equals area. You've been working with that in grade school, I'm sure. What if length times width, I don't need the dot, but I'm going to put it there for emphasis, gave you a 0? Well, how do you get rid of the area of a rectangle? Well, you can get rid of the height. Right, here's that area. Let's get rid of the height. What happens to the area as I get rid of the height? Oh, disappeared. So either L could equal 0 or W could equal 0. Right? That's what you do. So let's look at this problem. Let's look at this problem. X squared plus 5x equals 0. Well, this is called a product. Length times width. Most famous product we probably have. So the question is, if we can see what makes a 0, if we can write a product, if we can write this sum as a product, we might be able to easily see our answers. Well, first rule is take out what's common. Where L, my length is represented by the letter X, my width is represented by X plus 5. And if that's going to equal 0, then either the length equals 0, which in this case is X equals 0, or the width equals 0. And if the width is represented by X plus 5, and we want that to equal 0, I think we can see our answers of X equals 0 or negative 5. So you solve that by writing it as a product. Let's try another one. How about x squared plus 5x minus 6 equals 0? Well, you may have anticipated we want to write it as a product. And earlier, I think we already did this one. I think this was the x and the x and the 1 and the 6. Hope you remember what we did maybe 10 minutes ago. We want a positive, so the bigger number wins. And now what x's work? Well, this is my length, this is my width. What number makes the length equal 0? 1. What number makes the width equal 0? Negative 6. And we're solving a quadratic equation. Let's try another one. X squared minus 2x equals 0. All right, maybe you're anticipating what we need to do. Write it as a product. Can you spot your answers? They're isolated terms. That, if it had a 0 in place of x, 0 times anything is 0. In other words, I would have 0 times 0 minus 2 if I let x equal 0. And what do you get when you do that product? I hope you say you get 0. Therefore, x equals 0 as an answer. And it comes from the first factor. And what makes that 0? I hope you said 2. So let's put 2 up here. 2 squared is 4. Minus 2 times 2 is minus 4. What do you get? I get 0. I found an answer by writing it as a product. We don't always write quadratics as products because sometimes you can't. We'll worry about that later. Right now, if you spot something that looks like this, your first step is to say, can I write it as a product? Right? There's nothing common, but I think we did this one before too. 2 numbers that multiply out to be 14, 2 and 7. Add up to -5, minus 7 and 2. Add up to -5. What gets me x squared? X and an x. Can you see your answers? What makes that 0? An x value of -2. What makes this 0? An x value of 7. Let's see if 7 works. 7 squared, 49, minus 35, plus 14. I don't think that worked. Did I make a mistake? Oh, I did a typo here. I did the last problem. I thought I did this one earlier. X squared minus 5x minus 14. X minus 7, x plus 2 is correct. I plugged in a 7. Oh, I copied it wrong. Okay, this should have been minus 14. Right, I was going on muscle memory. So I butchered that. So now it's correct. Now it's correct. And so now if we put a 7 in, we can see 49 minus 49 is 0. So a little trouble here seeing the print. Eyes are getting old. All right, we're getting there. And you're just relaxing and watching the video. So now we're going to actually do a binomial square. Did you remember the shortcut? If you didn't remember the shortcut, you got to do 4 plus 3i times 4 plus 3i, which we will do. We will do both. But did you remember that you square the first term? You do the product, which is 4 times 3, 12i. And what do? We got to double it, 24i. 3i times 3i is 9i squared. Right? So for instance, 2 times 3 is 6. And 6 squared is 36. So where does it come from? It comes from 2 squared times 3 squared. 4 times 9. Okay, so when you square something that has 2 parts, you got to do both parts. And because this is in the parentheses, that's very different than this. That does not equal the same thing as 3i squared. I'm talking too much here. So what does this become? I squared changes positive 9 to negative 9, and I'll put it with the integer plus 24i. And that gets me 7 plus 24i. I'm going to do the next 4 problems quickly, just so you're not spending your entire night looking at a math video. But I hope you are just watching and pleasantly sitting back and trying it osmosis. So we worked on these today. 7 minus 2i. They're on your SATs. And you're not taking those for a couple of years, but it'd be nice if you get them right. So what did we do in class today? We conjugated, right? In an English class or a language class, you conjugate verbs. So we're gonna change the tense here. You remember what to multiply by? 7 plus 2i. 7 plus 2i, which is the number 1. That's the number 1. It's not going to change the size, but it's going to change the look. 3 times 7, 21. 3 times 2i, 6i. Now, what's going to happen with minus 2i times 7 and positive 2i times 7? What's going to happen with minus 14 and positive 14i? they're gonna cancel, so we don't have to do the insides. We just have to square the outside, 7 times 7. 49. A negative times a positive is a negative. 2i times 2i, just like the last problem. 4i squared. What does I squared do? It changes -4 to +4. And there's your answer. 21 plus 6i over 53. That's what you're gonna have on Friday. Some numbers like this, just a little different, and you have to get enough practice in to absorb that skill. All right, 2 or 3 more problems, then I'll upload this and then I'll call it a day. All right, solve x minus 2 squared plus 5 equals -11. Now, whenever I get students at the pre-calculus level, I still have to teach this because everybody gets drilled into doing that out so much as a skill that when they get to the solving part, they multiply this out and make the problem harder than it is. We have an equation, which means we have an intersection of 2 graphs. And the way that you can solve any equation with an isolated x is to isolate it further. Move all the operations to the other side. The first operation that we're going to move is the simplest one to move. Over here, we have something plus 5 equals -11. Well, what plus 5 equals -11? I think -16. So this whole thing right there has to equal -16, which means addition of 5 becomes subtraction on the other side. Now, how do we isolate x minus 2? Because we got to get rid of squaring. What undoes squaring? Square rooting. And most people forget to say plus minus for most of the semester. Maybe you won't, but odds are you will. Now, we talked about negatives. The square root of -1 is imaginary. So the square root of -16 could have been written as the square root of 16 times the square root of -1. And what's the name for the square root of -1? Imaginary. So you should write, anytime you have a minus sign, you should erase the minus sign and put the letter I after the square root. So now we have x minus 2 equals plus or minus 4i, because we know what the square root of 16 is. And subtraction of 2 becomes addition of 2 on the other side. So let's go back to the original. Just briefly, did I copy it right? Yes. So x minus 2 squared plus 5 equals -11. And I just want to make one quick point. That's the graphing form for a quadratic. It's a cup shape up. 2, 5 is the vertex. And -11 is lower than 5. Y equals -11. And if you think that graph is intersecting that, you're imagining things. That's enough said on that. We'll build it up further in class. Okay, 2 more problems. 2 more problems. I know it's a lot right now, but we got to get a foundation going. So we're going to stick with these 20 problems until we see maybe 10 of them right, and then we'll add a problem. Okay, we'll stick with it until we can get 10 problems right. And until we get 10 problems right, where the brakes are on, but as soon as we get 10 problems right, we'll add 1 or 2 problems a day. And then we'll see if we can get a foundation going. So we have -2/3, x minus 4 plus 5. I hope you recognize that as the equation of a line. It's the first problem you've been doing on every worksheet the whole first week. So let's graph that line. I'll give a little XY axis here. 4 gets me 5. Should be able to see a 4 gets you 5. We're going down 2, 3, 1. When you go up 3, 7, 10. So there's some points that we can connect. So 10, 1, let's put 10, 1 way out here. 7, 3, let's put that there. Let's look at 4, 5, maybe there. So that's our line. And we want to know, when does this When does that hit a height of 12? Height of 12, this is a height of 5, so 12 is out here somewhere. I think it's gonna take a negative number, maybe around -3. I don't know, I didn't give it a lot of thought, but some negative number, maybe -5. I wouldn't surprise me if it was more than that. But we're just gonna do the mechanics of solving this. So what's the first thing you do? You subtract 5. That gets us 7. That still leaves us -2/3 x minus 4. What do you do next? Most algebra textbooks say multiply by the negative reciprocal, right? Or the reciprocal, whatever. I think it's easier for you to understand if you look at this number here and say, that's division by 3. What's it gonna be on the other side? I hope your brain just said multiplication. And 3 times 7 is 21. Then what do we do next? Multiply by -2 becomes what on the other side? Division by -2, so that's -21/2. You always put the negative in the numerator. And now we got to add 4. I'm going to add 4 here and erase this. You can always replay it. And we've been looking at that too. How do you add an integer and fraction? Well, you make the integer look like the fraction. Right? So what are you dividing by 2 to get the number 4? How do you make something divided by 2? Well, you do 2 times 4 is 8. Okay, so what's -21/2 plus 8/2? I think it's 13/2 negative, which is -6.5. Yeah, so it's over here somewhere. So I trust that answer because I looked at it graphically and it matches up. Last problem, yay. All right, this one might take you a week or 2 to be able to do, but we'll stick with it until you get it. We just started in class today, 9i to 31. And we said I squared is -1. So the question is there a way to write I to the 31 in terms of I squared? Well, how many times do I have to get to do I squared to get close to 31? I hope you say 15, because 15 times 2 is 30. So this becomes 9 times I squared, 15 times, that gets me to 30. How am I going to get to 31? I need to multiply by another I. And for this point in time, I'll put a dot. We'll drop the dot later. So I have 9 times that times that. Is there another name for I squared? Yes, -1. So now's the time you make the parentheses -1. And you're going to do that 15 times. And then you're going to multiply it times I. So let's do -1 15 times. A negative times a negative is a positive. So a 2 times got me a positive. Another negative, 3 times get me a negative. Another negative 4 times gets me a positive. 5 times gets me a negative. Sure looks like a pattern here. It looks like if I do it an even number of times, if I do I squared to an even number, I get a +1. And if I do it to an odd number, I don't get a +1, I get a -1. I'm doing it to an odd. That means I'm getting -1. If I do it 15 times, it stays negative. So I get 9 times -1 times I. Your answer is -9i. All right, and these 20 problems are coming your way tomorrow. Let's see how many you remember how to do. All right, and if you remember how to do them, that means you're putting something in your pocket. And the more things you put in your pocket, the better you're going to feel and the better I'm going to feel. All right, so we'll see you in class tomorrow. Let me freeze that. Oh, end the meeting. There we go.